Chemistry 2.2, atomic structure in the periodic table. The diagram below shows the electron structure of an element in the periodic table. So the first thing I do as soon as I see this question is work out the number of electrons, and that means I can work out what element it is. Using the X to represent the electrons, draw similar diagrams to show the electron structure of the elements which lie directly below this one in the periodic table. So sodium, directly below sodium is potassium. It's got a number of electrons at 19. And then I just draw them in the shells, making sure I followed the 288 rule of the electron configuration. Lies directly to the right of this one in the periodic table. Now, that is not directly to the right of potassium. You're going back to the original one at the top. So directly to the right of sodium is magnesium. Again, it's got number of electrons 12. I worked that out. And then again, following the 288 rule, I plotted the electrons in their right place. Carbon has two different types of atoms, which are represented by carbon 12 and carbon 13. Give the term for different types of atom of the same element. So elements that are the same element but different mass numbers or number of neutrons are known as isotopes. The second question then, it says it's giving you some information about elements A through E, and it says that these are not the chemical symbols for the elements, that's just how they've been numbered. Question that loads of people leave out, so I've highlighted it. Complete the table. So the first one asks you to work out the number of the mass number. So I've written a helpful hint next to it, protons plus neutrons. All I've then done is add the protons and neutrons together to work out the mass number. C asks you to work out the atomic number. I've written on the side, same as electrons, all the same as protons, up to you. So the electrons and the protons are 6, so straight away I know that that's what the atomic number will be. This one then says, ask you to work out the number of neutrons. So I've done mass number minus atomic number, so 23 minus 11, and I'm left with 12. Give the electron structure of element D. So element D has got 10 electrons. You can see that there, confirmed by the atomic number. So you remember that 2 only go in the first shell and then 8 can go in the next shell. So it's like drawing out the shells, but instead you're just writing it. Use the information to explain why this element is found in period 2 and group 0. Group 0, as it is, has 8 in the outer shell, so it's got a full outer shell. Full outer shell means group 0. Period 2, as it has 2 shells. Choose the letters A through E of the atoms that represent isotopes and give a reason for your answer. So B and C. B and C, they have the same atomic number but a different mass number, or the same number of protons and a different number of neutrons, which means they are isotopes of each other. Question C then, a really nice easy question to start you off. Asks you to fill in a table all about the atomic structure. So, what is the charge of an electron? Negative. What is the mass of a neutron? Neutrons and protons always weigh the same. It's a nice question. Then it says potassium is represented as 39 and 19. Element X has 9 electrons, 10 neutrons and 9 protons. Write the information of element X in the same format. So you can see I actually made a mistake before I did it right. I was writing it the wrong way round. So I worked out the mass number, which was neutrons plus protons, which was 19, and then I put the number of protons, which is also the atomic number, below. Chlorine has 2 isotopes, chlorine 35 and chlorine 37. Complete the table below. So, atomic number, straight away I can work out the number of electrons because it's the same as protons, the same as the atomic number. Number of neutrons, like we said before, that is mass number minus atomic number, and that would give you 20. It goes on then to talk about the atomic number of sodium, which is 11. Place a tick in the box next to the electron structure of sodium. So sodium's 11, 2 would go in the first shell, you'd be left with 9. 8 would go in the next shell, you'd be left with 1. 1 would go in the final shell. Element Z is found in group 2 and period 4. So group 2 means it's got 2 in its outer shell. Period 4 means it's got 4 shells. So straight away, I know that it's only got, so I'm looking for 4 shells. I'm left between the bottom 2. Then I know it's in group 2, which means it's got 2 in the outer shell. So by process of elimination, knowing my facts about groups and periods, I'm able to tick that box correctly. Question number 4 is talking about what you might observe when you put potassium in water. Describe the observations when potassium reacts with water. It will turn into a ball. That ball will float around and spin around the water, and then it might light and pop with a lilac flame. During a class demonstration, the potassium exploded. Suggest what might have caused this to happen. Potassium is reacting with the water. If it's exploding, you've most probably added more potassium to the water than you maybe needed. Complete and balance the symbol equation for the reaction between potassium and water. So potassium forms potassium hydroxide and hydrogen gas is given off, which is that funny smell you can smell when you do the demonstration. I've then balanced out the equation and then gone on to work out where I need the extras from. So I've never filled in that side there, but I've balanced it out and worked out where I needed the extras. Finally then, question number 5. This is the only type of 6 marker you can expect to see on a question like this. So state and explain what information this gives you about element E. So this is element E here. You may wish to refer to the key on the periodic table to help you with this answer. So straight away I'll be going back to the key, working out. So first thing I wrote is mass number equals 35, atomic number equals 17. So that means that you can work out the number of protons, neutrons and electrons, which I've done by here. I can also then, because I know the number of electrons, go on to work the electron configuration out. I then know what group and period the element is, and then I can actually then go on to the periodic table and find the element. So that is exactly how I work this 6 marker. As you can see, I didn't write it in full sentences, I just bullet pointed everything I could find out about that element.